hello. How are you? Just been thinking about calculus lately. I thought I might do a video about it. Just feeling good. Anyway, area between curves. Let's do that. So graphed is the function f of x equals x squared plus 1. So x squared plus 1, that's an upward opening parabola. Here she is. That's that one. That's f of x. And then we've got g of x is the downward opening parabola. There she is. And I want to find the area enclosed by them, right? So I want to find the space in between these functions. That's all of this stuff here. I'm not going to shade all that in. It'll take forever. But that's what I'm looking for. Now, I can tell that it's I don't know, was that negative 2.5 to 2.5 or something? I don't know. It's an estimate. But I can figure out what the bounds are, but I don't know actually how to get the space, even though I know integrals are area. It's just what do I do? So this is actually how we're going to view it. We take the integral of the top function, which for us was g of x. Do the integral from a to b for g of x. Right? And that's all the space you see there shaded blue. Right? That's the space under the downward parabola. I can subtract the area under the upward parabola. And all that leaves me is the space between them. So that's what we do. Just the integral of top minus bottom. That's what you have to do. Top function minus the bottom function, then you just do an integral. Nothing fancy. So if you have two functions f of x and g of x, you need to find the area between them. Then you do the integral of f of x minus g of x. And that's it. You'll have bounds. Subtract the functions from each other. Make sure that you do this one parenthetically, right? So it'd be f of x minus g of x maybe is even better. That has to be done parenthetically because what if g of x is x squared minus 2, right? Then that negative distributes. So you need to make that substitution parenthetically. Even though people don't like it when I say parenthetically. I don't care. I'm going to say parenthetically. Now you might be wondering, well, which one comes first? The one that comes first is whichever one's on top because it has more space, right? So then the next question is, well, how do you figure out which one's on top? Pick any x value in between the bounds. Don't pick the bounds. Some point on the interior of the interval, and you see which y value is greater. Bigger is the wrong word. Greater. Whichever y value is greater, that's the one that goes on top. That's the function that will go on top. Okay, so there's several slides talking about what we're doing, why we're doing, how we're doing. Now let's do. Find the area between f of x equals x cubed minus 2x and g of x equals 2x on the interval 0 to 2. I know I want to do the integral, right? I know it's integral from 0 to 2 of something dx. I just don't know what the something is. Is it f of x minus g of x or is it g of x minus f of x? So let's look at the bounds. 0 to 2. 1 would be easy to plug into that, so let's find f of 1. Be 1 minus 2 is negative 1. G of 1 would just be 2 times 1, which is 2. Which the 2 is the greater one, right? So that's the one that's going to go first. G of x will go first because 2 is greater than negative 1. So 2x minus, parenthetically, get over it, x cubed minus 2x. So I'm going to distribute the minus. And let's combine terms while we're in here. So I got 4x minus x cubed. I like simplifying my integrand. It makes life easier, right? I only have 2 terms now. And I don't have to deal with a minus of 2 terms thing. This is just nicer. Now I need to do the antiderivative. It's 4x squared over 2. Increase the power, divide by the new power. X to the 4th over 4, evaluated from 0 to 2. Which, I think I'm going to simplify that too. That looks easier to look at. Alright, so let's plug in 2. Minus plug in 0. And this is a polynomial, so it all goes away for 0. Not that big a deal. And this is 8 minus 2 to the 4th is 16 over 4 is 4. So 4. Ta-da. Okay. Find the area enclosed by f of x equals x squared and g of x equals x. Same idea. It really is the same idea. I need to do the integral of top minus bottom, but I don't know the bounds this time. Well, let me give you a little sketch. There's x squared. That's x. Oh, I did not draw that well. I need to draw it better than that. Like that. Now, what I'm trying to find is this right here. So I need this point, and I need this point, right? Those are just the intersection points. To find those, you set the functions equal. You need to find the intersection points. Those become your bounds. To do that, set the functions equal and solve. That's all we're going to do on that. It's not going to be too crazy. Hopefully if the functions get real crazy, you'll be able to find the solutions on your graphing calculator, which we probably won't use today, not in this lesson, but we'll start to use it even literally in the next lesson, so we'll be using it a lot. Find the area enclosed by x squared and x. So I'm going to set those two equal. Do not try to take the square root. Don't divide by a variable. You've got a quadratic term, and you've got a linear term, right? Power of 1 on that side. You got to move it all over. And then factor. I get x equals 0, x equals 1. Those are my bounds. So now I have the bounds of the integral. Still don't know which one's on top or bottom. But if this is my interval, well, plugging in 1/2 would probably be pretty easy. Let's find f of 1/2. It's 1/2 squared, which is 1/4. G of 1/2 just is 1/2. 1/2 is greater, so g of x goes first. Got the integral from 0 to 1 for x minus x squared dx. Anti-differentiate. Evaluated from 0 to 1. That's 1/2 minus 1/3 minus 0 minus 0. Common denominator. And you get 1/6. We're kind of quick on the arithmetic, but it's 1/6. All right, let's do another thing. Side-by-side region. So this isn't really top minus bottom, right? So the space that I'm looking at that's over here, this right here, that little almost triangle, but it's bent on the left side, so I can't really call it a triangle. That's the space I want. That's not the space where there's one function on top and there's one function on bottom. Really what it is it's the area under this function until there, and then it's the area under this function for the rest of the interval. Right? So we've actually done something like this before. You just probably didn't realize it's what we were doing. You just break it up at the boundary, right? So that's where it's basically where the function changes definition. You break it up, which is what it's going to say over here. To find the area, you're just going to do two integrals. You do the integral from, what was that, 0 to 2? No, 0 to 1. Make sure that you're checking your scale, right? There's the 2, so this is 1. 0 to 1 for whatever the parabola was. What was it? X squared plus 2x? Plus the integral from 1 to 4, just finishing out the integral, of 4 minus x. So then you just evaluate those two integrals and add them up. That's all you got to do. So when you have two regions that are sitting next to each other, not like it's two functions on top of each other, just break it up into two different integrals. It's not top minus bottom with that. I'm not going to actually do that integral out. I think you could figure it out. Just antiderivatives. It shouldn't be too bad. But yeah, that's the end of this video. So I'll... every time I talk, look. Oh, wait. Okay, bye.